market. Here we have an example of the treatment. This is sewage sludge from a stabilization lagoon in Brazil, and it's the same sludge 22 minutes later. So you had this volume to manage, now you only have this. And this is so aerated that dries easily in 2 or 3 days. Here we have a special effluent from wood flooring. Sorry about the picture, but by the time we took that, we had no idea we would be in an international competition. And this is the same aquarium. Here is the electrode. The water is a little yellow, but you can see that the sludge is all here. Here we have effluent from Jim's wash, and the same effluent 30 minutes later with the water proper for use. And here's the sludge. Here is the sludge itself after the colander, and the same sludge 48 hours later. So you can see that the volume is so
5 minutes, please.
Here we have a sludge from biodiesel effluent treatment. Biodiesel is something very good, but nobody tells about the effluent. Okay, and it's very difficult to treat as well because it's full of emotions. And you have the same sludge 48 hours later. You can see that the sludge looks like little pellets. So that's what allows you to recover the material. Oh, it's over?
No. Sorry.
She fixed the clock.
Oh, I have 5 more minutes?
Yes.
Thanks God.
Sorry.
It's okay, thank you.
Good, we get to the good parts.
We have more. So in a physical analysis, we had 2 different scenarios for special effluents and for sludge removal. In the case of the special effluents, we were talking about 10 HREFs that are movable, that can be taken to the industries, treat the effluent, allow the water reuse, and can be taken somewhere else with a capacity of 1 cubic meter per hour, working 15 days per month. So the initial investment is around $640,000 for an internal return rate of 61%. For the sludge removal, it's a little bit different. We predicted an installed plant because offering a service, but not movable because we want to encourage the continuous sludge removal. It's something we want to encourage. It's not like the stabilization lagoons where we will have to wait 5 or 20 years to go there and clean it, okay? So we want to encourage that. With the same capacity, full-time work, we predicted 85 E3Fs. Only Sabesp runs in São Paulo around 400 sewage treatment plants. So we're just considering a small part of that market. And the internal return rate is about 15%. And I know this is a little bit high, it's a little bit difficult to imagine, but the fact is that the cost of the treatment for us is very low when you compare to how much you can charge for the service. Because they are paying so much more for transportation, for landfill and everything, since you don't have all that thing, all that transportation and all that landfill disposal, you're saving a lot of money. So it allows us to charge more for our service, okay? That's why it happens. So the conclusion is that this business plan is a tool to introduce a practically unknown technology in Brazil that was once considered not viable because the conventional electrocoagulation has the same problems of the other conventional treatments. The sludge is as wet as the other ones. So you have to centrifuge, you have to put in a press filter, you have to transport in this final disposal the same way. Our innovation allowed us to save all that money with the sludge, so we need to broadcast that important innovation, okay? The potential of the technology is even higher because it can use as a coadjutant technology for water and sewage treatment. If you have water with algae problem, with heavy metal problem, we can all treat with that. And for example, we can also use it as a coadjutant technology in a sewage treatment plant where we can install and increase the capacity of treating. Because if they last 8 hours to treat now, we can treat it in 30 minutes. So if we already have a plant that is built, we can increase the capacity of that plant. So they won't need to expand, okay? So in this perspective, the market is expanded to all the wastewater and water treatment in the world. And the strengthening of this technology in Brazil will be essential to reach countries with even bigger problems than ours, like China, India. They have even bigger problems than Brazil. Thank you very much.
Sorry for the confusion.
Don't worry.
Sorry.
I hope I didn't miss anything. Well, but that's what we have the questions for.
So if I'm a potential customer, what's your argument to me that why I would want to adopt this technology?
Why?
Yeah.
Because you have a smaller plant. You're going to save a lot of money when constructing.
How much am I going to
Save?
pick a size of one of your target customers and tell me how much I would say.
Okay, I would say, for example, the conventional treatment, you would need 8 hours. So if you needed, for example, 160 square meters, in this one you would need 1 square meter, 10 square meters, sorry. It's 16 times less because it treats 16 times faster, okay? Because the treatments have different hydraulic detention times, okay? So I'm comparing with the fastest ones with biological, okay?
Right.
Biological that are usually 8 hours the treatment.
And hydraulic detention time means you fill up some tank
Yeah, because
and you wait. And
exactly.
something is happening while you're waiting, but it's not a continuous process, it's a batch
No,
process.
it's a continuous, but you need to, the water that comes in, the tank should be big enough so that it stays for the hydraulic detention time there, and it will only come out after the hydraulic detention time. It's a project parameter. Engineers use that to...
It's a flow, relative flow rate issue.
Yeah.
Got it, okay.
It depends on the type of treatment. The physical-chemical treatment takes around 3 hours, okay, to coagulate, to decantate.
So I think I understand the value proposition. I just don't understand in terms of exactly who are you selling to? Is it the sewage treatment plants or the actual industrial producers of wastewater?
Both of them. These are the two markets that we had to approach because it's two very different purposes. So one of our market is the sewage treatment plants. Of course, it can also be used as the sewage treatment itself. But we first want to solve the problems that they already have. Okay, let's solve the problem of the sludge, and then if they approve the technology, we can expand for the new sewage treatment plants.
So as you roll it out to other countries, it would be to who? It would be, if it were in the U.S., you would be selling it to sewage treatment plants, right?
The sewage treatment plant here in San Francisco, we were there 2 days ago. They do the same thing. They put polymer in the sludge, they coagulate it, and they put it in a centrifuge, and it comes out with 20% of solid that they have to transport.
Right.
And so we would use that technology to treat the sludge that they are now centrifuging, putting polymers, and transporting with 25% of solids. We could flotate, electro-flotate, create that sponge aspect sludge, dry it in 2 or 3 days, because the problem of the regular drying bags, if you put the regular sludge in a drying bag, it will take around 60 days to dry to 40% of solids.
Right.
So it would demand a huge area.
So
it's all about the area.
Yeah. So by and large, so in the U.S., probably would be to sewage treatment plants, not to industrials, right? But in Brazil, you would sell it to the industrial concerns plus the sewage.
Yeah, it can also be used as industrial treatment because you can also install a plant over there. We approached this market for movable ones because in Brazil we have this reality. It's too expensive for the company to buy their own treatment plant, so we can go there, treat their effluent for them, charge for the service, give them the water for use, and take it away. But if they want, they can also have an installed plant, okay? Like a conventional one.